Okay guys, so you're welcome. This is a continuation of the initial class that we had on equations of motion. So in this particular class, we'll be discussing equations of motion. I will be looking at second and third equations of motion and their derivations. Second and third equations of motion and their derivations. So this is No Man Science Tutors Online, and if you have not subscribed to our channel, please subscribe to our channel, click on the notification button so that when we upload a new video, YouTube will notify you. Also give us a thumbs up, give us a comment below. You can reach us through the WhatsApp number that is showing on your screen, and you post any problem that you have in physics. We'll discuss them with you and reason with you. Our aim and objective is for you to be your best in physics. So you're welcome to our class for that. I remain Otobo Michael. So right away, please get your writing materials so that you can focus and concentrate on the class for today. Alright, so we are going straight to our class for this morning. Welcome. Okay, so equations of motion. For this particular class, we're looking at the second and third equations of motion. The second and third equations of motion. So consider that a body moving into uniform acceleration must have had an initial velocity u before attaining a final velocity v. So to find the distance traveled by this body, we know that distance traveled is given by distance s is given by average velocity average velocity times time. Okay, so if you have this at the back of your mind, then to derive the second equation of motion becomes easy, right? Okay, so alright, so distance is average speed or velocity times time, right? So for you to find the average speed, since you have been given the initial velocity and the final velocity, the average of these two velocities will be the sum of the two velocities divided by 2. So the average velocity of this body is the sum of the initial velocity and the final velocity divided by 2. And so when you do that, you have this average velocity is equal to u plus v all over 2. U plus v all over 2. Right? So, but we know that from the first equation of motion, we got that v is equals to u plus at. This is what we got from the first equation of motion. V is equals to u plus at. So if you substitute this v, which is u plus at, into this equation that you have here, substitute, instead of you having v here, put u plus at. If you do that, you are going to have this, that average velocity will be equals to u, which is this, plus u. This v now is u plus at, so it is u plus at. Now collect like terms together, you have 2u, right, plus 80 all over 2. Now this equation, you can also rewrite it this way, that 2u all over 2 plus 80 all over 2, right? So by the time you divide this, you are going to have u plus half 80. This is what you will have as your average velocity. Now you know that distance is equal to average velocity or average speed times time, right? This is what you know, that average velocity equals to distance or displacement all over time taken, and displacement or distance represented by s over t. So displacement all over time is equals to this, which is this average velocity that we got in this particular first instance. Is that okay? So in this particular first instance, this is what we have here. Alright, So what you now do is that here now you do cross multiplication. That's you cross multiply, right? So if you do that cross multiplication, you are going to have this as your final equation. Okay, so if you do that cross multiplication, the t you have s will be equal to u plus half at, all of this multiplied by t. Okay, so this will now give you ut plus half at squared. So your s, which is distance, will be equals to this. So this is your second equation of motion. This is your second equation of motion. This is the second equation of motion. Is that okay? So this is your second equation of motion. It's as simple as that. So please know how we started it and the various steps that we took in order to derive this equation. Know that average velocity is the sum of the velocities given, that is the sum of the initial and final velocity divided by 2, and then substitute the first equation of motion into this and do your carry out your algebraic calculations to get this particular equation. From there, average velocity, distance all over time, do your cross multiplication, and then you arrive at the second equation of motion. Why you need to know how to derive this is that for some questions you will look at the variable that you are given so that you will know if you are looking for distance. So if you are given an equation or a question and you have acceleration and time on it, and maybe you also have initial velocity, and you're asked to find distance, then this is the equation that you should apply. This is the equation that should apply. So this is the second equation of motion. I hope this is clear and is simple, because now we're going to combine, for us to get the third equation of motion, we are going to combine the second and the first equation for us to derive the third equation of motion. So now we are going to derive the third equation of motion. Okay, so for us to derive the third equation of motion, we saw that from this second equation of motion, we got that average velocity is equals to displacement all over time, or distance all over time, right? So that was what we got. And we also saw that distance traveled is equals to what? Average velocity times time. Average velocity times time. And from our first equation, okay, from the second equation, we are told that average velocity is equals to what? Initial velocity plus final velocity all over 2, right? So initial velocity plus final velocity all over 2 times time. Now from the first equation of motion, we had that from the first equation of motion, we had that v is equals to u plus at. Okay, so if we make t the subject of this formula, we're going to have that t be equals to what? V minus u all over a. So if we have t like this, we can actually substitute this t into this equation. We can substitute this t into this equation. So if we substitute t here, what we're going to have would be, we'll be having v plus u all over 2 multiplied by v minus u all over a. Okay, so this will be your S equals to this. Now if you do this, if you solve this, work this out, this will give you S is equal to U squared plus U squared minus, okay, so this will give you U squared minus V squared all over 2A. So you can actually do your rearrangement here. You can actually do your rearrangement here so that you have that, or do your cross multiplication to have that 2AS is equals to U squared minus V squared. And when you do rearrangement on this equation, if you rearrange this equation, you will have that V squared is equals to U squared plus 2AS. So this is your third equation of motion. Now this equation applies when you are given initial and final velocity, and you are also given, when you are given either the initial velocity or the final velocity, as the case may be. If you are given initial velocity and you have the acceleration and distance, and the time is not given to you, you apply this equation of motion. So any question on motion where you don't have the time given to you, this equation of motion should readily come to your mind to apply it. Right, when you have acceleration and distance, you have initial velocity, and time is not given to you, this equation readily comes to mind for you to make use of that. Okay, so this is the third equation of motion. This is the third equation of motion, right? So that is the third equation of motion, and that is what I've discussed now. So this is the third equation of motion. This is the third equation of, this one is the third equation of motion. So far we have discussed three equations of motion. Okay, so this is a summary of what we've discussed so far. This is the first equation of motion. V is equal to U plus AT. So if you have a question where maybe you are giving the initial velocity and acceleration is given to your deceleration, and you are asked to find the final velocity, and you have the time, you can use this equation. If you are looking for distance in any of the questions that has to do with motion, you can either use this equation or this, depending on the variables you are given. If you are not given time and you are looking for distance, then this third equation should apply. But if you are given time and acceleration and you are looking for distance, this second equation should apply for you to use. Also, there are other equations that we have discussed. We have discussed that distance equals to average speed times time, and that also that average speed is distance all over time. So these are the summary of the equations that we have discussed. In our next class, we'll be discussing, or we'll be carrying out calculations using these equations that we have derived and discussed so far. So thank you for your time, and thank you for also listening. But guys, if you have not subscribed to this channel, please, what are you waiting for? Subscribe to this channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, you can reach us through this WhatsApp number that is here, when we will discuss any problem that you have with you, and then we'll help you to solve your problems too. So thank you so much. We will see you in our next class.